Good morning, everyone, and welcome to today's demo session on LoadRunner Masterclass with Dynatrace APM tool. This is Mohan, and I have around 11 years of experience in performance testing, and I worked on all the tools, like major tools like LoadRunner, NeoLoad, and JMeter, and I have good experience with monitoring tools also. I'm the trainer for this particular batch. So as a part of this today's demo, right, I'm just planning to give you some insights on holiday sale failure case study first, and then I'm just planning to go ahead with the course content part. So as most of you are already working, right, so we know like how much important is the holiday sale for us, right? So generally, like, holiday sales are extremely important for online business especially. So during these sale events, right, what will happen? Companies will offer huge discounts as well as some special promotions to attract the customers. So because of that, what will happen? Because of these specific offers, right? They are expecting like a large number of users to visit their application or website, right? So because of that, obviously large number of users will visit that application or website at the same time during the sale day. So one way it is good. Why? Because it will generate the revenue. But on the other side, right, if you take, there are going to be some major technical challenges that we may face. So can anyone just give some idea like what sort of technical challenge that we may face during the holiday season? Please feel free to turn on your mic and make it as interactive. What sort of challenges that we may face during the holiday season on a high level?
A very large number of users logging in at the same time.
Hmm. Will
Uh,
obviously put
hmm,
more burden on the server, right? So if
yes,
more number of users are accessing the application at the same time, then obviously there is some burden on the application servers, right?
yes,
So, and also you must make sure that your application servers or your servers are able to handle that much of high traffic or sudden spike in the traffic. If at all, if your servers are able to handle that, then that's fine, right? If your servers are unable to handle that traffic, then it leads to crash, right? Your application will crash after some time. That's how generally it works, right? So if such particular system failure is going to happen during the big sale, right, what will happen? Obviously it is a serious impact on our revenue as well as on our customer trust and on our brand reputation, obviously, right? So if the system is going to crash, and if your users are unable to place orders during that particular sale period, then there will be a huge loss of revenue over there. So that is the reason why in this session I just want to discuss, or I just want to give you a walkthrough of a scenario where an e-commerce platform crashed during a flash sale, and also I'll show you how performance testing could have prevented this particular issue. Hope we are clear with what we are going to learn, right? Any questions in this?
yes, Mohan, we are clear.
Yeah,
Yeah,
clear. Yeah.
thank you. So before going to analyze the failure, right, let's first try to understand the user journey of an e-commerce application. So generally, right, let us take one demo application. Like, I just don't want to name the big e-commerce applications here. So let's name our application, e-commerce application, as Trend Cart. Okay. So let whenever users are going to visit our Trend Cart e-commerce application, which is a online shopping platform, right? So first, what they will do is they will browse the products first on the website, and then they are going to search for a specific item that they are looking for. And once if they found that particular item, right, they will add that item to the cart, and then obviously finally they are going to proceed with the checkout and payment, right? These are all the different stages that are involved in the user journey of an e-commerce application, right? Out of all these stages, which particular stage you feel as the critical stage for business? In terms of business, okay, which particular stage is the most critical stage for us?
Hi, Yubraj here.
Yes,
I
Yuvraj.
was having some issue with the mic before, but I got it fixed.
Okay, sure.
So
Got it.
the critical business flow or the transaction would be the checkout.
Yes. Checkout
Checkout,
as
it
well as
make payment.
payment, obviously, right? So the both checkout and payment are the key business stages, are the key transactions for us. So if,
Mhm.
let us say, if checkout is failed or payment is failed, right, then obviously we are going to see huge loss of revenue. So that's the reason why we need to make sure that this checkout as well as the payment transactions are going to work in a proper way, even under the normal load conditions as well as the peak load conditions too. Right? That is our whole aim. So let's try to understand the application architecture of this particular e-commerce application. Right? So let us say if user is trying to search for a particular product, okay, what he's going to do, he's going to send one request to the server, right? First, that request will go to the CDN. What is CDN, guys? Full form of CDN?
Content delivery network.
Yes, content delivery network. So what CDN will do is it will help us to deliver the static content like images, CSS files, and JavaScripts in a faster way. Okay, these CDNs, right? Generally, it will be near to our data centers, near to our locations. Okay, so whenever if user is going to access any kind of data, first it will go and check in the CDN. If that data is present in the CDN, then we will get the response from the CDN itself directly, which reduces the latency here. Okay, and the performance of the application is going to be improved here because of this, right? So let us say if the data is not available in the CDN, then what it will do is it will go and hit that request to the load balancer. Now let us say the user is searching for some particular product and that data is not available in the CDN. Okay, now what will happen, the request will go and hit the load balancer, and this load balancer, what it will do is it will distribute the load in a proper way among all the servers which are available. Okay, as we are searching for the product, right, and this load balancer will distribute that particular request to the specific service. Okay, so in, if you observe this application service application servers here, this is a microservices cluster, right? Here you can clearly see that we have a product service. So whatever the request that we are sending in terms of searching a product, right, it will come and hit this product service. Then obviously what this product service will do is it will try to hit one request. Okay, one second, let me take a pen here. So it will try to search for that particular product in the redis cache first. Okay, so if that particular product related information is available in the redis cache, then it will take that information from the redis cache and it will give that input to the user. Okay, so the user can see the products details over there in his particular front end. So if that is not available, let us say if that particular product information is not available in the redis cache, then automatically it will go and hit the database and it will bring the data from the database and it will send that information to the user. This is how it will work. Okay, so once after getting that particular information from the database or from the redis cache, right, so if the product is available, then the user is going to select that particular product and he's going to click add to cart button in his front end. So once after clicking the add to cart button in the front end, right, so it is automatically going to trigger the cart service here. So what this cart service will do is it will go and check for the inventory first. So whether that particular product is available in the inventory or not. Okay, if the inventory is available, then it is going to add that item to the cart database. Okay, inside the cart database it will store that information, and then that information is going to be sent back to the user again here. Immediately what the user will do, he is going to click on the checkout button, right? Once if he's going to click on the checkout button, then one request will go and hit the order service now. Why? Because once after doing the checkout, okay, so order service will trigger, and again this order service will verify whether the inventory is available for that particular product or not. If the inventory is available, then it is going to check whether that item is added to the cart or not, and then immediately it will send one uh, request to the payment service. Okay, it will hit the payment service and the payment gateway will come into the picture, and we are going to do the payment here in the payment with the help of payment gateway. Once the payment is done successfully, then obviously it will give input, it will give again the result as a order placed successfully message to the end user finally. Okay, this is how a typical, like a common e-commerce application architecture is going to look like. We are going to have multiple services on the back end, and these services are going to be called from the front end when and where it is required. And also remember one important point here: whenever if we are trying to hit one particular service, it may internally hit other services also. In our case, if we are trying to search for the if we are trying to hit the cart service, internally it is going to hit the inventory service first, and it will verify whether inventory is available or not. If at all, if inventory is available, then only it will add the item to the cart. Okay, so this kind of internal calls or internal API calls is going to happen on the back end, where we can see all those things, like where we can see like which particular service is going to be triggered whenever if we are hitting this request, and whether it is calling any internal API services or not. So where we can see that? Any guess from your end?
You
Hello.
means what?
In the APM tool, we can see that.
Yes, in the APM tool. So whether it may be the Dynatrace, or whether it may be the New Relic or Datadog, whatever it may be. So we can see that in the APM tool easily.
Yeah. Hello, Mohan. Actually, I have one question. Whether you are sharing your screen or not, because I am not able to see your screen. That's why I'm asking.
I'm already sharing my screen.
Yes,
Hmm.
we can see your screen, Mohan. At
Actually,
least
I'm
I can.
unable to see. That's why I'm asking.
Oh, okay. Others, I think others they can able to see my screen. One second. What I'll do is let me. One second. Let me stop my screen share and I'll do it again. Okay.
Yes.
What about now?
Yeah, yeah. It is visible. Thanks.
Okay. So this is how a typical e-commerce application architecture is going to look like. Okay. Can you please go on mute? I'm hearing some background noise from your end. Yeah. So any questions in the e-commerce application architecture part? Okay. Considering that as no, I'll proceed further. So let's try to understand, okay, on this particular application during a normal day, how the traffic is going to look like. So as I said, right, we are going to name our application as a trend cart e-commerce application, right? So on this application during the normal day, right, we are going to have a daily active user count of 30,000 users. So during the whole day, okay, we are going to see like some 30,000 users are visiting this application. This is on a normal day. Okay, and on the peak hour, right, so the concurrent users are going to be like around 3,500, and they are going to place some 1,500 orders within 1 hour on the peak hour especially. Okay, on the peak hour we can see like 1,500 orders, and the average response time during the peak hour for all the transactions is around like 1.4 seconds. This is how the normal day traffic is there on that particular e-commerce application. So with this particular traffic, the application is going to perform well Okay, and there are no issues in terms of response times or in terms of checkout process, right, and the payment process. So that's what they have observed, right? And they are planning to go for a sale. Okay, in order to attract more number of users, they are planning to go for a sale, and that's the reason why, okay, they want to introduce some discounts to the users to attract the customers here. So they started to introduce one new feature called dynamic discount engine. So what this dynamic discount engine will do is, it is going to, like, whenever the users or customers is going to apply the coupon during the checkout, right? So the checkout service will be triggered automatically on the back end, and this service will internally hit one more service called dynamic discount engine service. Okay, so what this dynamic discount engine service will do is, it is going to validate the coupon, and it is going to calculate the discount. If the coupon is valid, it is going to calculate the discount, and it applies the promotional rules also here. In order to validate the coupon, in order to calculate the discount, and in order to apply the promotional rules, every time it need to interact with the promotion database. Why? Because the coupon data and other discount rules information is stored in the database itself, right? So whenever if we are applying the coupon internally, what is happening, let's try to understand this. This is very, very key part, right? So internally it is calling one service called checkout service, and this service, it is going to hit the dynamic discount engine service, and in order to verify or calculate the discount, it is going to make multiple database calls here on the backend. One for validating the coupon, one for calculating the discount, and one for verifying whether this particular coupon is related to this promotional rule or not. Okay, this is what is happening on the back end. So just before the sale, right? Just before the sale, they introduced this particular discount feature. Okay, so what they thought is, like, they have done some particular functional testing over here, and they verified it, like everything is working fine. Development team, they asked the QE team to test the functionality of this particular feature, and QE team, obviously they have done the functional testing, and they verified the login part, and they verified whether they can able to search the product and add the items to the cart, and whether they can do the checkout properly or not. They have done that verification from their end. Okay, and they mentioned that everything is working fine, but what they missed here is, they didn't executed the performance testing for after introducing this particular new feature. They feel like the infrastructure will automatically handle this particular load, so because of that, they didn't executed any performance testing over here. They skipped the performance testing, and they moved that particular code to production, and the application went live. This is what happened. Okay, so this is a bigger mistake, guys. Remember, whenever, if we are expecting like more users or more traffic on our application, then if any change, if we, even though it is a minor change, right, then obviously we need to execute the performance testing before going to the production, before moving our code to production. Okay, so that important point they skipped here, right? Now the sale day event started here, and all of a sudden, right, they started seeing like huge number of users or huge traffic on this application, okay, within a short time, right? So on a flash day sale, right, they have seen around like 150,000 daily active users, okay, with a peak concurrent users of around 18,000. Okay, and the orders per hour is rise to like 7,500. On a normal day it is like around 1,500, but because of this particular flash sale, right, so the orders count also got increased to 7,500. And during this particular time, they have observed the average response time as around like 20 seconds here. Previously it was around like 1.4 second or something, but now the average response time got increased to 20 seconds. So after, like, initially it went well, but after some time what happened, okay, there is a sudden rise in the response time, right? And because of the sudden rise in the response time, the application, right, completely got crashed, and they started seeing some checkout failures here. Obviously, when the response times are too high, we are not going to simply stay on that application, right? We'll simply come out and we'll go and visit other website and we'll book our products for there. So this incurred a huge loss to them. Okay, so that's the reason why we always prefer to go for performance testing before any kind of sale. Okay, so here they miss this particular performance testing process. That's the reason why they need to pay this huge amount of loss here. Are we clear till this part? Any questions? Please feel free to ask. Guys, please be active. Yes or no?
No questions so far from my side, Mohan.
No questions.
Okay, thank you. Okay, so now let's try to understand what exactly the issue happened over there, right? So because of the heavy user traffic, right, the application servers became very slow. Okay, and it is taking much time to give the response back to the end user. Okay, so because of that, most of the users left that particular website within 3 seconds of the time. So they waited for 3 seconds, 5 seconds, and still the page is getting loaded. They got frustrated and they left that particular website here. And some people, they keep on waiting on that application, okay, in order to book the product. So obviously, the page loading times are increased, and some people, they faced issue like they are unable to add the items to the cart. Okay, some people, even after adding the items to the cart, they are unable to do the checkout process, and some people, they are unable to do the payment process. They have seen a lot of issues here, and finally the application server got crashed, right? This is what they have observed here. And obviously this is going to be a big loss for that particular company who started that sale, right? So now they started digging into the root cause of this particular issue. Okay, so now they started understand, they took help of one monitoring tool here. Let us assume in our case Dynatrace, right? So they opened Dynatrace, and they started verifying during that particular time period what exactly the issues that they have faced, right? In the Dynatrace or any monitoring tool, okay, you can clearly observe the different types of metrics, right? The metrics may be in terms of response times, in terms of error rate, in terms of CPU utilization, memory utilization, disk utilization. You can see all those metrics related information in any monitoring tool, right? Similarly, during that particular sale period, especially when that particular system crash occurred, they added that particular time period in the monitoring tool, and they have started seeing some monitoring alerts triggered at that specific point of time. And when they observe deeply, right, they have seen like some high response times here, and some like lot of errors are happened during that particular time period, and the CPU utilization also increased to 97% over here. So they try to dig deeper on this, and because of that particular high response times and failures, right? So some carts got abandoned here, and they have seen some order failures, and obviously it affected the revenue on a whole, right? So they try to dig more on this, and they try to understand where exactly the issue is. So because of that, they verified each and every service. Okay, so and they identified the issue is with the checkout API here. Someone turned on the mic, can you please go on mute? Okay, so please make sure your mic is turned on only when you are alone, guys, so so that it won't disturb others. Okay, So what is happening here is they verified like the checkout API is taking much time here. Because of that, they have seen the cart failures as well as the payment failures here. So they identified like they have observed the normal response times as 1.4 second during the normal day. Okay, but during the peak sale day, right, what happened, the response time increased to around like 18 seconds. They identified that the database is overloaded. Because of that, this checkout API is getting failed. So we already discussed, right? Whenever if we are hitting the checkout API, internally it is going to call the discount engine, right? That discount engine will automatically hit multiple times to the database in order to fetch the coupon details, in order to verify that coupon details, in order to apply that discount, in order to calculate that discount, right? And in order to provide some good price to the customer, it is going to make multiple calls to the DB, right? So because of that, the DB got overloaded, and that is the reason why we have seen some high response time here in the checkout API. That's what they have identified with the help of monitoring tool. And at the same time, right, they verified the database CP utilization also. So all of a sudden, right, during the normal traffic surge, right, the CPU utilization is around 40%. But during the peak time, during the flash sale especially, the CPU utilization got reached to 100% here. So these are the two major things that they have identified here. One is the checkout API response time, okay, is one issue, and the second one is database CPU utilization. Along with that, right, along with these two, they have also identified two other issues too. One is the payment service delay, and the other one is the infrastructure limitation, right? So these are the four major root causes that they have identified, or the bottlenecks that they have identified for this particular sale without any performance testing done before the sale, right? Now they started thinking like missing performance testing is a bad decision, right? So now they started feeling like this is wrong, and they started asking the QE team to do the performance testing on this application, right? So that is the reason why, guys, the performance testing is so important in the places where more traffic is there. Okay, so now let's try to understand the production release with performance testing process here. So if the production release with performance testing is going to be there, then how it is going to look like? How the performance testing is going to resolve that issue is nothing but, so whenever if we introduce the performance testing, obviously we need to take help of the performance testing tools like JMeter or LoadRunner or Gatling or NeoLoad, right? There are a lot of performance testing tools that are available in market. So we'll take help of those tools, and we are going to start sending the virtual users, okay, with the help of those tools, right? And these virtual users will simulate the user actions like how a normal user do the actions on the browser, right? So these virtual users also will simulate the same user actions, and the request will go to the server, obviously, and it will hit the server. So here, what we are trying to do is we are going to start testing the application with a minimal load first. So with a minimal load, we are going to test the application performance here. And after, if we feel like the performance is good with that particular load, we'll increase the load slowly and we'll do the same test again. So like that, we'll keep on increasing the load here till we are going to see the issues. So in this case, right, if you observe, around 14,000 users, right, we didn't find any issues. But once the user count got increased beyond 14,000, right, then the application team, they started seeing some issues on the backend. Okay, so and we are able to see that issues also on the Dynatrace APM tool here. So now the test, we are going to stop that test here, and then we are going to do some analysis here. So what sort of analysis we are going to do is nothing but we'll open the Dynatrace and we'll try to understand which particular services are taking much time. Okay, especially which API is creating that issue. Okay, if it is a database issue, then what sort of database issue that we are facing over there and how to resolve that, right? That we are going to do as a part of our performance testing as well as engineering over here, right? So now they identified like the same four, they are able to replicate the same four issues or bottlenecks that they have seen in production, right? So let's try to understand how we can uh, how we can reduce that particular issue, how we can overcome that, right? So generally what happens here is whenever if we are seeing some API issue, right? Like in our case we have the checkout API issue, right? So the checkout API is internally calling the discount engine, right? Every time that discount engine is sending one query to the database and it is hitting the database continuously, right? So even if you are trying to search one particular product also, okay, that particular product information, in order to fetch that particular product information, right, it will send one request to the database and it will fetch the data from the database. Unnecessarily we are putting some burden on the database here, right? Instead of that, if we use the redis cache over here, if we use the redis cache in the middle, okay, then what this redis cache will do is, for the first time whenever if we are requesting something from the database, okay, it will fetch the data from the database properly and it will store that information in the redis cache up to some time, right? So within that particular time period, if some other person is going to ask for the same information, right, instead of sending the request directly to the database again, it will give the information back to that particular user from the redis cache itself. This reduces the number of requests on the number of hits on the database, right? This will improve the performance of the application in one way. So API catching is very, very important here whenever if we are going for a sale kind of events, right? So Redis cache can resolve that issue in a proper way. Here also the discount engine, if you take a discount engine example, the same thing happens to the discount engine also, right? Internally it is hitting like 3 or 4 multiple calls to the database. Now if we introduce the Redis cache over there, then obviously instead of hitting those many requests to the database, we are going to simply get the information from the Redis cache directly. That will resolve the checkout API issue, right? Now let's try to understand the other issues too, right? So we have seen like the CPU, sorry, database CPU utilization got increased to 100% from 40%, right? So why this happened? If we understand that, like every time, like for the write queries as well as the read queries, obviously we are hitting the primary database itself every time. That is the issue they have observed. So in order to overcome that, they maintained some separate database for read queries, that we are going to call it as read replica databases. Okay, and they are using the primary database for only the write queries here. That means whenever if we are creating any order or updating the inventory or doing the process payment process, right, at that time only it will go and hit the primary database, the request will go and hit the primary database. Otherwise, whenever if you are browsing some particular products or whenever if you are triggering any search queries, whenever if you want to see any product details, right, at that time it will go and hit the read replica databases and it will fetch the information from there, so that there won't be much burden on the primary database. So once after introducing the read replica databases option here, they started seeing like the CPU utilization came back to normal again. Okay, this is one uh, particular resolution they have provided, which is in terms of database CPU utilization here. Okay, when it comes to the payment process issue. We have seen like payment process issue also, right? During the payment also, payment processing also, we have seen some issue, right? So during the payment processing, right, as of now they are using like a synchronous payment processing process. So how exactly the synchronous payment processing process will work is, whenever the customer will do the checkout, right, it will go and hit the checkout service, and internally it will call the payment service. And here it is going to wait for the payment response. Here the checkout service, right, what it will happen, it will wait for the payment response. So this is the synchronous call. Synchronous call here is nothing but it is going to wait till it is going to get the response back, with so without doing anything. So if it is going to sit idle for some time, obviously there are possibilities that the payment process will fail in the middle after some idle time, right? If there is some issue with the payment gateway, or if the payment gateway is taking much time to give the response back, then obviously there are possibilities that we may see some payment processing issues here, right? So they observed this synchronous payment processing issue over here. So because of that, they modified the synchronous processing to asynchronous processing here. Now in the asynchronous processing, what will happen is the customer will hit the same checkout service, and the checkout service will obviously hit the payment processing queue, right? Here they are going to introduce one payment worker service. What this worker service will do is it will search for that particular response. If at all if it is not getting the response back, okay, it will put one worker node over there, and it will simply go and work for another user. Once if we get the response back, then it is going to send the reply to the customer again, right? So this process, this asynchronous payment processing is going to resolve this issue here, right? So there are no more payment failures over here because of the asynchronous payment processing, uh, as the user is not sitting idle, as the request is not sitting idle over here for some time, right? So that is the advantage of going for asynchronous payment processing when compared to the synchronous payment processing. Okay, so they introduced the asynchronous payment processing instead of synchronous payment processing, and which resolved the issue of payment processing during the checkout time. And coming to the last bottleneck that they have observed, they introduced the auto scaling infrastructure here. So previously what happened, like let us assume we have three servers here in the application layer. So all the requests are like are coming from the user is going to be sent to only those three servers in the previous case. Now they introduce the auto scaling option with the help of Kubernetes, right? Now this auto scaling process will trigger more number of servers or nodes here, and whenever if more number of users are accessing this application, okay, then automatically auto scaling process will trigger, and based on the required number of, based on the request, right, based on the request, required number of servers will be updated automatically, auto scaled automatically here, and that resolves the issue of auto scaling here. Okay, they introduced the Kubernetes here, which is not there before. So in this way, with the help of the monitoring tools, they can identify the issues, they can find out the root cause, they can find out the bottlenecks as well as the root cause, and they can simply provide the solution for each and every root cause here. After identifying all these issues, after fixing all these issues, now they went for the sale, right? This time the sale went very well, and they didn't find any issues. So on a whole, right, on a whole, if we take without performance testing, I can say like any flash sale or Thanksgiving sale is going to be a disaster. But with performance testing, we can say we can see a good success rate in terms of Thanksgiving sale or flash sale here. This is how it is gonna work. Any questions here till this part? Any questions or concerns? Please confirm.
No, so far.
Okay. What are the different challenges or the situations? Are you faced these kind of issues anywhere in your work experience, or any other issues? So I just took only one small piece. Okay, we have a lot of other things to discuss over here, but anyhow, I can't discuss everything in one session, right? So I took this basic example so that it will be clear for everyone. Okay. Any other challenges or any other bottlenecks that you have identified during your uh, work? Can you please, if you want, you can share it.
Yes, Mohan. Basically, the problem is when we don't have enough resources. Resources means like CPU or memory in AWS, right? So
Hmm.
that could be a bottleneck. I have seen in my project, and the mostly is with the inefficient SQL queries as well. The queries keeps on, the queries is taking more than like 30 seconds to return, and the uh, the I mean like every query is not resulting not giving the results in time, right? So it's causing the CPU to spike. So I've seen those kind of issues in my project, in past projects. Yeah.
Yeah, yeah. Obviously, here and there it is same, right? Whatever that we discussed. So for the first issue, we can go with the auto scaling, okay, option in order to reduce that CPU and memory utilization, especially on AWS with the help of Kubernetes. And for the second issue, we can go with this database replicas as well as the Redis cache by introducing the database replicas or Redis cache. In most of the applications, right, these are going to be the common issues or common bottlenecks that you can see. Okay. And apart from this, there are more other bottlenecks also there, but most commonly you're going to see these bottlenecks in most of the applications. So that's why I've chosen only these bottlenecks for demo purpose. And I explained how we can go with a solution also.
Sir,
Okay. Yeah.
hello.
Go ahead.
Yeah, just I want to ask you one question regarding the asynchronous thing. So can you open the slide?
Mm-hmm.
So here the checkout waits for payment response, right? So here the payment worker sir is what it is doing actually. It is engaging the end user or what?
Other so sorry, where exactly?
Yeah, yeah.
Payment workers you're
What it,
saying?
yeah, what it is doing actually.
See, these payment workers, right? See, instead of waiting continuously with the one user request itself, okay, they will simply go and serve the other user requests also.
Okay,
Okay, so they will send the first user request to the external payment gateway till it is going to get the response back, right? It won't
hmm.
wait. Okay,
Okay, okay,
it will
okay,
serve the other users requests
okay.
parallelly. So that is nothing but asynchronous here. So
Yeah,
but in
okay.
our synchronous case, what is happening, it is going to wait till we are going to get the response. That will create the issue.
For each user, for each customer, right?
Yeah, for each
Okay,
customer, you can say. Yeah.
okay. Got it.
Okay. Any other questions from anyone? Okay. If not, I'll quickly cover the course content for this particular training part. So let's quickly go with the course content part. So as a part of this particular course, I have divided into multiple modules. Okay, don't think like module is nothing but a daily session kind of thing. Okay, so for completing one module, I may take like 2 sessions, 3 sessions, or 10 sessions also. Okay, so I'm just dividing the course into multiple modules here so that it will be more clear for everyone. So let's go for the first module. So in the first module, I want to cover the introduction to performance testing by keeping in mind that there are few people in this batch who are going to have basic knowledge on performance testing, right? So that is the reason why I just want to cover like what is performance testing, what is performance testing life cycle process, right? And what are the key performance metrics that we are going to consider, and why we need to go for load runner tool when we have multiple other tools options, right? I'm going to cover all those things. Along with that, I'm going to cover each and every stage of the performance testing life cycle in detail. Okay. So for each and every topic, I'll provide some assignment. Okay, I'll ask you to do some assignment by like in terms of creating the NFR document or performance testing strategy or traversal flow document for a given application. And also I'm going to ask you to define some key performance metrics, which is nothing but response time, throughput, and etc. Right. So I just want to prepare some documentation over here as an assignment for the module 1. Coming to module 2, I'm going to give you the introduction to LoadRunner. So here I'm going to provide you the architecture of LoadRunner, and I'll explain you how the architecture is going to work. And if you understand that architecture, working with LoadRunner is so simple. Okay. And also I'll introduce you what are the components of LoadRunner that are available and how to use each and every component whenever it is required. And also I'll explain you about the protocols which the LoadRunner is going to support. And I'll start introducing the Vusion, which is the main component for scripting process in LoadRunner. Okay. So as a part of assignment, I'll provide you the software, LoadRunner software, the current version software with you. Okay. I'll share that software with you so that you can install the current version on your machine. And also I'll ask you to record one application. Okay. One web HTTPS protocol based application. Okay. With the help of Vusion. And also I'll ask you to identify a list of 3 supported protocols in LoadRunner. This is the assignment for module 2. Coming to module 3, I'm going to give you the overview of Vusion. Okay, like Vusion scripting basics. I'm going to explain you the code that we are going to see in Vusion first. And based on that, I'll explain you how to create the scripts, how to record the script, record the flow, right? And how to play back that particular flow, and what are the different basic functions that are available, web functions that are available in LoadRunner, and LR functions that are available in LoadRunner. And also I'll explain you how we are going to do the parameterization in LoadRunner, what are the different ways in which we can do the parameterization, right? So all those things I'll cover as a part of module 3, along with advanced parameterization concepts, right? Which is very, very important. We should know about like this advanced parameterization concept. That is going to be really helpful while you are working on your projects. Okay. So for that also a specific assignment is provided over here. You can just take a look of that. Okay. And coming to the next module, that is related to correlation. Okay, so I'll give you some introduction about what is correlation and how to do the manual correlation. Especially I'll concentrate majorly on the manual correlation only. See, there is one option called automatic correlation also that is available in LoadRunner, but I won't prefer to start with automatic correlation. Okay, if you start with automatic correlation, obviously you will end up with nothing, right? You should know which particular web functions we need to use it in order to do the manual correlation process. And you need to know the attributes of each and every web function. In interviews they may ask you like explain which particular web function you have used in order to correlate a specific dynamic value. At that time you need to explain that particular web function along with the attributes. So that's the reason why I'll prefer only the manual correlation, but I'll show you how we can do the automatic correlation also, and how we can create the frameworks also, which is going to be really helpful for you. Once if you create any framework, right, you can use that framework directly for the other scripts, which will reduce your work in terms of correlation especially, right? So that I'm going to cover here as a part of module 4. Okay, and there is a specific assignment for that module 2. And coming to the next one, I'm going to give you some advanced scripting concepts. I'm going to introduce some advanced scripting concepts here. Okay, like I'll explain you some advanced correlation techniques, how to handle the dynamic values whenever if we have only the left boundary, whenever if we don't have any right boundary, right? Whenever if we don't have any boundaries at all, right? So how we are going to handle those kind of situations, I'll explain as a part of this module. And also I'll explain you what are the different custom functions that are available in Vusion and how we can use that. And also I'll introduce you the error handling and error handling concept, along with how to debug the scripts in a proper way. And I'll explain you the runtime settings, the key thing that you need to know. Okay, these runtime settings are very, very important settings that you are going to use it during the test execution, especially, right? So, but we need to know about these runtime settings priorly. So as it is there in the Vusion itself, I'm going to cover this also as a part of advanced scripting here. Okay, coming to the next module, that is the performance test case design and strategy. So with the help of Vusion, what we are going to do is we are going to do the scripting. Once the scripting is done, then we need to take help of controller here to do the test execution setup. Okay, our test scenario setup. So here I'm going to do that. So we are going to do the workload modeling before doing the test execution setup with the help of Little's law, and we'll see all the possible cases over there. And once after doing the workload modeling, we are going to simply do the test execution setups with the help of controller. And we'll see how we can do that in controller and what are the different options that we have in controller over there. Right. As a part of module 6, I'll cover that. And as a part of module 7 also, in extension to that, I'll explain you how we can create the user groups, how we can create the ramp up ramp down patterns, and how we can do the different types of test execution setups, and how we can monitor the metrics with the help of controller, right? How the like I will explain each and every concept related to controller as a part of module 7. Coming to module 8, I'm going to explain you like the analysis part. That means we are going to do the test execution over here in the module 7 itself. Once after completing the test execution, we are going to take another component help here called analysis component. So with the help of that analysis component, we are going to analyze our result. Whatever the test execution that we have done, right? We will get one result. That result we are going to analyze here with the help of the analysis component. And I'm going to explain each and every option in the analysis component, which are going to be very, very useful for us in order to drill down the issues over here. Okay, and also I'll explain you how we can create the reports. Okay, how we can customize our reports, and how to find out the root cause analysis over here. Okay, and also I'll give you some troubleshooting and optimization techniques information also as a part of module 9. Coming to the module 10, I just want to give you some experience. Okay, I have one more machine with me. So what I'll do is I'll use that machine as a load generator. Okay, and I'll connect to that machine. Okay, and I'll trigger a test by using that machine as a load generator, so that you can send the request with the help of another machine. So I'll introduce the distributed load testing concept over here by introducing the load generators here into the picture. I'll show you practically by connecting to that particular machine. So this is going to be really a good session and helpful session for you going forward too. Okay. And coming to module 11, right, I'm going to cover the performance testing for web services, especially the SOAP as well as REST APIs. Okay, how you are going to do the performance testing of web services, I'm going to cover it here as a part of module 11. As a part of module 12, I'll cover the true client scripting on a high level. Okay, so by taking one application, I'll explain you how you can use the true client protocol. Okay, nowadays in most of the interviews, they are expecting this true client experience also. So you can also get that experience over here by working on the true client scripting here. Okay, I'll explain you how we are going I'll give you some introduction to true client protocol first, and then I'll show you how you can record the application with the help of the true client protocol, and how you're going to enhance the script with the help of true client protocol, right? So I'll explain that as a part of module 12. As a part of module 13, I'll explain you about the database testing. So how you are going to connect your connect to your database with the help of LoadRunner. Okay, there are a few LR functions that we need to use: LRDB connect, LRDB disconnect, LRDB execute SQL statement, LRDB fetch, right? So how to use these LR functions in order to connect to the database and trigger the queries from LoadRunner, so that you can test the database performance here. So that I will cover as a part of module 13. As a part of module 14, right, what I'll do is I'll cover the virtual table server, which is also one more important part. Okay, so I'm just going to cover that virtual table server. In real time, we are going to use this. Most of the companies, they are using it, and most of the companies, they feel like it is not useful for them, but knowing this will be an added advantage for you for sure. So I'll explain you how to use this virtual table server. I'll give you the software also, so that you can install it on your machine and you can try it on your local itself. And I'll show you how to connect to that virtual table server, and how to use that particular virtual table server functions in LoadRunner in our Vusion script especially. Okay, so I'll explain each and everything over here in module 14. Coming to module 15, right? I'm going to cover the Dynatrace integration. See, whatever the test that we have done previously, okay, without monitoring tool, I'll take that particular test and I'll explain you how it is complex for us to understand or to identify the bottleneck over there. And I'll execute one more test by adding the Dynatrace tag in our LoadRunner, okay, by integrating our Dynatrace with LoadRunner. And then I'll explain you how easy it is to have this to understand the bottlenecks over here in the specific test with the help of monitoring tool availability. Okay, that I will cover as a part of module 15. And I'll explain you the basic options as well as the advanced options that are required for a performance tester. Okay, especially in terms of Dynatrace, okay, to identify the root cause analysis. That I will cover by showing some examples over here. So on a high level, this is the complete course content that I am planning to cover over the next 30 days, 30 to 35 days. Any questions or concerns in the course content? Please feel free to let me know.
So, sir, I want to ask you one thing.
Mhm.
So, actually, currently I'm working on JMeter and I have a good knowledge on JMeter.
Mhm.
So while learning this tool, so are you going to make us work on any some complicated flows like that?
See, obviously, we will work on complicated flows itself. Whatever the applications that we are going to explain you, right? For looking purpose, it may be the normal application, but when you start working on that, you will feel the complexity over there. That I can assure you.
Okay. Yeah.
And for sure, LoadRunner is one of the important tool, okay, that is there in market, top tool in market. Most of the MNCs, they will prefer like LoadRunner. Why? Because they will get the clients also in that way, right? So they are going to prefer only the LoadRunner, right? Nowadays they are showing interest on NeoLoad also, because of multiple options, the multiple better options that we have, right? But LoadRunner is a standard tool, right? Most of the companies nowadays also, they are going to prefer LoadRunner apart from other tools. But when it comes to the JMeter, we know like it's an open source tool, and we don't have any proper support over there. But here it is not like that. So here we have the option, help support option is there. OpenText is now taking care of this LoadRunner. Like they will provide the support for you whenever if you purchase some license. So that is the major advantage of the LoadRunner tool. And that particular support is also going to be very quick and very useful for you.
Sir, one more thing.
Mhm.
In JMeter, as we do the distributed load testing, but since this LoadRunner is a licensed tool, so
Mhm.
here also we are going to do the distributed load testing or
Yes. As I mentioned, right here also we are going to do the distributed load testing. See, distributed load testing is nothing but we are taking another machine and we are using that machine as a load generator. That's it, right?
Oh,
So here we are having an option called load generator. We will get one software, okay, while installing the like we can install that load generator software in another machine, and we can use that machine as a load generator, and we can send the traffic to the server with the help of that machine.
okay.
That setup I'll explain you clearly by connecting to another machine, and I'll show you by switching to multiple machines over there.
Okay.
Any other questions from anyone? Please feel free to ask. Okay. You,
Mohan, one question. You were saying that you have explained the different type of testings with the example because load stress, endurance
yes, yes.
is
That
also covered in this
yes,
part.
yes. That I will cover as a part of the scenario management using LoadRunner
Okay.
controller. See,
Okay.
whatever the course content that I have provided, as mentioned, right? I just provided it on a high level. Okay. So module
Okay.
7 means I'll cover the complete controller part. So that will take
Mhm.
a minimum of 3 days or 4 days or 5 days. It depends on the work. Okay. I can't provide like I can't put each and everything on the slide. So that's the reason why I made it as a short and I kept it over here. But yeah, for sure I'll cover each and every type of test execution setup as a part of this training.
Okay. So these also cover the requirement gathering also. How we will collect the requirement and prepare, right?
Yes.
Travis document.
Yeah. In the first stage, in the first module itself, we have that. I'm just planning to cover as a part of this performance testing life cycle, right? I'll share you some documents also so that you can go through that. You can use that as a template.
Theoretical knowledge we have, but practical knowledge we didn't have to collect that.
Sorry.
That's why I'm asking. Theoretical knowledge we have that how to collect that, but when you come into the practical, we don't have that. That's why I'm asking.
So see, these are all requirements, right? If you know, if you understand the application, then you will come to know what sort of questions that you need to ask. See, these questions, NFR questions, most probably it will be the common questions. Okay, if it is an e-commerce application, okay, if you are working for 10 different e-commerce applications, right, projects, then the questions will be automatically same. Domain wise the questions may vary, okay, slightly here and there, but most of the questions are common. I'll explain you like what sort of questions that you need to ask and why you need to ask that questions. That also I'll explain you. No worries.
Yes, Mohan. But this is the toughest first for performance testing rather than doing the scripting and other things.
Yes, yes.
Very crucial part to start a performance testing because everyone will do this scripting and other things. It's not a problem. But when you come to that requirement gathering, it's proper way you have not done it, then it will lead to that improper results. That's
Ye-
why.
Yes, yes, I got your concern. Okay, I'll come up with a strategy. Okay, I'll come up with a proper requirement, and I'll show you the functional requirements of that particular application. Based on that, I'll explain you how you are going to ask the non-functional requirements. And we all know, right? Performance testing is a non-functional type of testing, right? So we need to ask questions, we need to ask the questions which are related to non-functional. So I'll explain you how we can prepare the document in a more realistic way so that it will be useful for everyone. Yeah, that I will do. Any other questions from anyone? Okay, if questions are not there, then I'll end the session here. I'll thank everyone for your time to this particular session. So let's meet tomorrow, and we'll start. I'll start explaining you the LoadRunner concept from tomorrow onwards. Okay. Thanks for
It's a
attending this
30
session.
days course, right, Mohan? What is
Yes,
the duration of this course?
yeah, it's 30 days.
4 weekdays.
Yeah, all weekdays only, Monday to Friday.
Okay. Okay.
No sessions on weekend, but if you have any questions and other concerns, right, I can connect with you on weekends. Okay, I'll plan a separate session for doubt session on weekends especially, so that you can connect with me on weekends and you can clarify all your doubts.
Provide the software for this to practice that
Yes,
runner
yes,
software.
yes, those who are enrolled, I am going to provide the software for them. Okay, and each and every software installation also I'll cover as a part of training, and I'll also explain you how to install the Dynatrace one agent on your machine, and each and everything I am going to cover in detail by providing all the softwares. Yes, any other questions, guys? Okay, thanks for attending this session. Let's meet tomorrow again.
Okay. The same time, right?
Yeah, same timing.
Okay. Okay. Thank you.
Yeah, thanks.
Thank you.
Thank you, Mohan.